The table below shows the cost of a gallon of 1% milk for several years. Use the linear regression feature on the graphing calculator to find the equation of the line of best fit for the data. Okay, that's the first thing we're going to do. When you're given time, time is always your x value. Time is always your x value. Also remember, when we plug this into your calculator, your x will become the L1 data, and your L2 data will always be your y. Independent, dependent. Now, how does time work? The very first year they give us will be x equals 0. And we determine the other years by the number of years after 1998 for this problem. So if this is 0, how many years is 2000 past 1998? It's 2 years. 2002 is 4 years, 6 years, 8 years, and 10 years. So instead of plugging in 1998 through 2008, I'm going to plug in 0, 2, 4, 6, 8, 10 for L1. You will always do that when you're given years for your x value. So let's start by coming up with that line of best fit. Please clear your calculator by doing second plus 712. And then hit the button that says Stats. Edit is already highlighted. I'll press Enter one time. Now in the L1 again, I'm not going to plug in the years. It's going to be 0, 2, 4, 6, 8, 10. In the L2 column, I'm going to plug in the price of a gallon of 1% milk for each year, the average price. I'm just going to check the data here to make sure everything's correct. Okay, so I have the data in, and now I'm going to quit out of this system by going second quit. And now I need to find the application that is going to provide us with the answer. So hit the button that says Stat and go to Calculate. Go down to Linear Regression, which is number 4. Most of you can just press Enter twice. Since I have a newer modeled calculator, I need to continue to press Enter until I get to Calculate. We should have the exact same answer. I want to take this answer and I want to put it where Y1 is. I don't want to round it. So to do that, find the button that says VARS and press it one time. Then go down to Statistics. Then go over to EQ and press Enter. We have now copied and pasted in our previous answer. Okay, so before we go ahead and look at it, let's look at our numbers. We're going from 0 to 10. 0 to 10. Okay, so this is below 0. And this is above 10. Okay, so 0 to 10 is within this range. Now the cost of a gallon of 1% milk, the average, okay, so this is my lowest number and this is my highest number. So I need to at least go below 2.57. Could I keep it at negative 10? Sure, but I know 0 is below that, and I'm going to go 0 to 6. I can always adjust. So I've come up with a range that allows us to see everything. Please hit second stat plot, and now I want to turn on so I'm allowed to see where are those points. These are the points, and this is my line of best fit. Okay, let's read part A. Use the equation of the line of best fit to estimate the cost of 1%. So we want to know the cost of 1% in the year 2015. So we're told the year, we want to know the cost. Okay, so I'm going to come over here. I know X is the year, so I know X and Y. I'm told the year is 2015. I don't want to write 2015. I want to ask myself, how many years after 1998 is 2015? Well, I know from 2000 to 2015 is 15 years, plus an additional 2-year gap. So X equals 17. You could also take 2015, and you could subtract it from 1998. So we're given the X, we want to find the Y. As a reminder, it's much easier when you're given the X to find the Y. Before I do anything, here's what I want us to look at. I want you to go to Windows. Right now, does our window go to at least 17? It sure does. If it didn't, I would adjust it. Go back and hit Graph. Now to figure out this Y, you're going to go second, trace, the value is 1, second trace value, and I'm going to type in 17. All right, what does this mean? We want to write a complete sentence. Not in the year 17, in the year 2015, we can estimate the cost of 1 gallon of 1% milk to be approximately $4.13. That's if I'm rounding to the nearest hundredth. We can estimate the cost of 1% gallon of milk to be $4.13 in the year 2015. 17 years after 1998 is 2015. Part B. Use the equation of the line of best fit to predict the year. So now we want to know the year. We don't know the X. And we know that the cost. So let's go back here. In what year will the gallon of milk of 1% exceed $5? So when does it hit $5? When is the cost $5? Okay. So when you're given the Y, I'm going to go back up to Y equals. Go to second number and put in a 5. Before I do anything, I want to see in the Y's, is 5 within this range? It is, but it's really close. So I'm going to change this to a 10 just to make sure, okay, 5 is within the range here for the Y's. I'm going to hit Graph. And I can see they eventually are going to intersect, but it's not with the one I can see, so I need to change my range. I don't care about all this here, so I want to take the X's and move them to the right. So right now the X's are between negative 10 to 20, and 20 is not far enough over. So I'm going to go from 20 to 30, choosing just some arbitrary numbers. I can adjust if I can't see it. Okay, and I can see they intersect right here. What does this intersection mean again? We're trying to figure out when is the cost $5. So to find that intersection, go second, trace, intersect, second trace, intersect. First curve just means what's the first equation. There's your first equation. It's the line of best fit. Second equation means what's the second equation you plugged in. And guess means go over the top of where you think they intersect. Now what does this answer mean? So we can estimate that between 26, from the start of the 26th year to the start of the 27th year, that is when the cost of 1% gallon of milk would be $5. Now what is year 26? Because it occurs during year 26. Okay, well the quick way to do this is to go, what is the beginning? It's 1998. I want to add 26 to 1998. So in the year 2024, we can estimate that during that year, the cost of a 1% gallon of milk will exceed $5.